Hello, everybody. Well, I think we're live, as far as I can see. Welcome to this Fetch's Field Trials Community Q&A. Really pleased to be here, and I'm here with Michael Reuter from Datarella, and we will be introducing to you. Hang on, let me just get this slideshow working. And so we have Michael from Datarella and we have Rebecca from Datarella. I would hand it over to them for introductions, but I'm the co-founder and CEO of Fetch.ai. And Michael, over to you.
Yeah, I'm the co-founder and CEO of Datarella, Munich-based enterprise blockchain solutions provider. Over to Rebecca.
I'm one of the blockchain architects at Datarella, sort of responsible for the requirements engineering and figuring out how all the parts should go together.
Cool. So today we have a plan which is to just give you a quick overview of Fetch.ai. I think a lot of you would have already known about us. It would be good to take you through what we do in terms of multi-agent systems, again, give you an overview. And most exciting bit for today is the Munich project, which Datarella and Fetch are going to be doing together. And then we'll do a quick tech summary, and there will be a presentation from Rebecca, just giving you an overview, and Michael will be taking kind of parts of it, and then we have the Q&A, which will open the floor to everybody. So just quickly, I'm not going to go too detailed because I think there's a bit more exciting stuff to go through later. We in this world today, and this is what we're trying to solve, we have all this increased complexity of different siloed kind of ecosystems. So everybody wants to have their own piece of the business and they're trying to hold on to the silo. So what that means is you extracting value, the true value of the data, doesn't always come about. And there's a lot of unused power in the economy which needs to be harnessed, and which would be done by putting all these siloed businesses together. So that's what we are trying to do, and we're trying to do it by saying there is a huge economy of all things, and what we want to do is bring them all together. Our approach is that machine learning and AI, as important as it is, it needs to be brought together, and our approach is to do it via multi-agent systems, where you give autonomy to agents, you give them the ability to communicate and connect with each other, you give them the ability to negotiate and exchange economic value, and so that's the key. And what we have realized is that the biggest and the best multi-agent system is actually blockchain and smart contracts. So we're putting a multi-agent system integrating on top of a blockchain. So that's what we at Fetch are trying to do. So what benefits does it give you? So what it gives you is you could run a multi-agent system where you can give autonomy to the agents can transact, they can represent, they can connect, they can negotiate value. But that unlocks this whole decentralized machine learning. So if you think about all these agents which are doing all these transactions, they're doing all these actions, and if you could leave the data within those agents and then try and give them a system, which is what we call collective learning, you could enable them to build intelligence collectively. And that's one of the key components of Fetch.ai. But you want to do this with a secure data sharing. So we have to be aware that we cannot just have the data available to public, and not everybody needs to be able to see that data. So we do data sharing in a very secure manner. So where does it all take us? Well, we have been many a times we've heard that we're trying to take too wide an approach on different sectors. That's really not the point here. The point here is the new multi-agent system is a new way of doing things. It's like saying, you have thousands of websites. How do you connect them? The thousands of websites could be in different areas, different sectors, but the way to connect them is using the internet. But okay, you now connected them. How do you find them? Well, we have Google who helps us find all these things. So what we are saying is you now go to the next phase of evolution, and you have, instead of websites, you have autonomous agents. They're doing different tasks. They're more active than websites. They can connect with each other. So what kind of sectors can they unlock? And the main sectors we're focusing on, where we can see a lot of potential right up front, is where you have multiple stakeholders. So logistics, mobility, energy, building management, in a sense where you have a network of buildings, which also brings in connection with smart cities, you have smart infrastructure. And on a lesser note, I think more towards finance, where you could give autonomy to different agents to carry out some financial tasks. Obviously, they're all linked together somehow, because you can't have smart city and logistic quite separated. They kind of blend in. And that's what we're trying to do. We're trying to break those barriers. A beautiful diagram from Bosch, which I always like to go through. I'm not going to go through it in detail because I want you to hear more what Michael has to say next in terms of his presentation, and what Rebecca needs to take you. But what I just want you to be aware, everybody to be aware, is that we are focusing on three main things. So you have agents, and with agents, we say it's the multi-agent system framework. How do you build the agents? What's the toolkits? How do you launch the agents? How do you actually connect them? What is the search and discovery mechanism? Then the next bit is, on agents, you have the network, communication, search and discovery. How do you connect? How do you transact? But another important bit here, if you'll see in all of this, is you need the information to come from the outside of the world into the Fetch world, and that is delivered by oracles. Now, oracles is a very crypto-based, it's gone very popular in the crypto space, but oracles are somebody who's going to provide you data which you can act on. So we have agents, we have the network, and we have oracles who will provide outside data inside, and it has to be reliable data. There has to be a whole architecture around it, and that's currently our focus. So field trials, this is the exciting bit. So we talked about all the hypotheticals, all the theory. Now we're coming to actually implementing something in the real world. People have been asking us for the last year and a half. When are you going to show us something which is going to be an implementation? Yes, absolutely. We are now at that stage where you're going to see, over the next whole year, you're going to see commercialization, you're going to see deployments, you're going to see field trials. And today's Crowdcast is mainly about that. We want you to kind of see, we're partnering with Datarella to deliver this, at least the step one of this agent-based system in Munich. And they will, we will go through that in a bit. But just to quickly touch on a few things. So we have smart infrastructure trials coming. We have parking network trials coming. Again, you need to see this not as separate siloed things. If an agent can communicate with smart infrastructure, it can also communicate with the parking network. It can also then enable or help and take help from decentralized delivery networks. So if you think about a network of agents finding you work for delivery, or the cars and delivering different things, humans, packages, food, and then you need to look at the other side, which is the hospitality, where you actually being able to book reservations while you're traveling and communicating with your smart infrastructure. So all of this, you need a central, at the moment we have the centralized thing of where all these things connect to aggregators. What we are trying to do is, rather than take a centralized approach, we're trying to create an open economic framework where you can actually connect with all these devices, and it's decentralized, and all the agents can find each other. So I'm not going to go through too much detail here because I think this is the more boring side. I'll jump this slide. So just to give you an overview of where Fetch and the Fet token sits in all of this. Well, it's the key component of all of this. To connect, to build the agents and launch them, you need Fet tokens to do that. To carry out search and discovery on the decentralized OEF, you need Fet tokens. You also need them when the agents exchange the data, when they exchange value, you need Fet tokens for that. What's happening is all these agents are operating and they're communicating with each other and they're building this collective intelligence. If you want to participate or if you want to add a skill to an agent, which in kind of you can actually use and enjoy those AI machine learning models from the collective learning, you'll need Fet, because that's the mechanism of economic reward. So you're running all of this, it's running on a network, and the network's fuel is Fet. But another interesting thing which I think we should remember, if you have these oracles which are providing all this information on the basis of which the autonomous agents are acting and doing stuff, you really need to make sure people are staking to provide the right incentives and they're not trying to game the system. So there is skin in the game. You all know perhaps about staking and how it works. But what I want to impress on is to get the agents to provide the right information into the system, you need people to stake so that we have the genuine data sets coming in. We have the genuine predictions coming in. So what have we done up to date? We've done parking agents. You guys have seen the videos. If you haven't, they are available. Come to our website. We have done a demo of the smart infrastructure that will also now go to field trials, perhaps very soon. We've done signs demo where you can communicate with the signs, you can communicate with the smart architecture. We've then also done some smart grid approach where you have the vehicles optimized based on the charging, electric vehicle charging, and we put it all together with optimization of the road network. So that's what we have done as research projects. Field trials, where are they coming? This gives you an idea. I think today we want to focus on Munich. We have we like to keep London and Cambridge because we're based here. But that's not to say that there's no other projects which are coming about. There's plenty which we'll be announcing soon. But at the moment, we have the hospitality and distributed delivery network coming. That's within the UK. And that's it from me. Hopefully I managed the time expectation, and I really want to put it across to you guys now, Michael and Rebecca.
Okay, thanks very much, Humayun. Rebecca, if you can come up with our presentation, please. So we have one presentation, and Rebecca will share it with you, and I will take over the first part. I will give a brief introduction to Datarella. So we are a Munich-based enterprise blockchain provider. With enterprise, we mean that we provide software to enterprises that must use the software now, today, so it must be ready, but it will use the software tomorrow and in maybe 5 years. So it must be stable, it must be resilient, so we cannot focus on the latest state-of-the-art technology, but we focus on what is doable right now. And that is where our products come in. Rebecca, next slide, please. So we have developed a wallet, and we will see what this wallet can do. So we call it a smart wallet. It has the very basic features like sending and receiving crypto, but it can do a lot more. We have built a wallet or an application that is called Smart Aid, together with a charity foundation that is up and running on smartaid.digital. you can spend or where you can donate money from €1 to €200 to charity projects all over the world. And together with the European Space Agency and UK Aid, we have developed something we call Track and Trust. That is a solution is usable for humanitarian and other supply chain projects. Next, please. We have started with launching our first solution in April 2017. So that is 2.5 years from that was 2.5 years ago. And so we launched an Ethereum-based payment network in a Jordan refugee camp for Syrian refugees who can identify themselves via this iris scanner, and then they use our wallet to pay with a token. It is displayed as Jordan dinar in this case, but they pay for all their stuff they buy on a daily basis with a token. And before they used the wallet, they used coupons or debit cards. And bringing in this Ethereum network into Jordan refugee camps has benefited, or the UN World Food Program has benefited from that by saving tons of money. So they are saving more than $10 million per year because there's no more fraud, data fraud, no more intermediaries ask for additional fees and so forth. Rebecca, next slide, please. We do more or less the same, but with totally different identification systems in Bangladesh, again, for the UN World Food Program. And next slide, please. And we do it for a minority population called the Rohingya. The Rohingya, they were expelled from their country some years ago from Myanmar/Burma, and they were rid of their identities. And we had the Rohingya project, that is a grassroots project, to regain their identity, to regain the ability to participate in the international financial network. And we provide them with our wallet that enables them to have transactions using a community coin, the R coin. Next, please. Then we have, as I already mentioned, a supply chain solution where you can go to the next slide, please, where we enable humanitarian organizations to track and trace their supplies throughout the world. And in this case, it is connected with satellite uplink. So even in locations or regions where there's a low or non-existent bandwidth, it's possible to track and trace the goods, and that again saves tons of money. Next, please. And that is how we work. So on the one hand side, the effects of our work can be seen on a worldwide basis, but the instruments and the tools we are using are very often very local. So we used that in Munich city center, and we had communication with satellites and tested everything with for this project right from Munich. Next, please. Then we have our smart wallet, and you can directly go to the next slide. That enables not only just sending and receiving crypto, but this smart aid donation platform as well. Next. And the next. And now we come to MZone. So since we are very practical people in Datarella, we are looking for blockchain and AI tech that is not only visionary, but it's what is usable right now. Because we have, as a small company, so we are just 35 employees, based in Munich and Gdansk, Poland, we have to deliver practical solutions that make sense, that come with benefits for many stakeholders. And so we thought about how to use autonomous economic agents to optimize the parking situation in a highly dense populated area such as Munich. Next slide, please. And since we last year started with the tokenization of a quite large office building in the city center of Munich, it's called the Connex building, we thought that it might be a good idea to take this Connex building and adjacent buildings to test whether autonomous economic agents can do their job and help not only the employees of the tenants in these office buildings to find their parking spaces better, but also to help the tenants themselves to dynamically exchange parking spaces between each other, and to enable landlords, when they have new real estate projects, to come up with meaningful concepts that prove that employees in future buildings will be incentivized to use public transport instead of driving with their individual private car to their offices. Then they will get their they will have improved application process for their new development projects. And last but not least, if you imagine how much CO2 emissions, how many CO2 emissions can be saved by people not searching for parking lots or even not using their cars at all, then it's a lot of CO2 emissions that can be saved. And the Munich City Council is very much interested in concept like this. And how that actually works, that Rebecca will demonstrate to you right now. Rebecca?
Yeah, I just needed to unmute myself. This will be very familiar to many of you. Anybody who drives often has to drive their car someplace and actually park that car. And most of the time we're driving around blind, trying to find where to park that car, and having to drive past potentially a lot of different spots that are often very full in order to find some place that we can park. Because everybody wants to drive their car and everybody wants to have a parking space. That obviously results in a lot of CO2. What we're trying to do with M-Zone is to make that process a lot smarter by making each one of those parking lots intelligent using Fetch autonomous economic agents. So that each one of the parking lots has a AE and is able to directly see which cars are going in and out of that parking lot using computer vision to recognize the license plates, and is able then to give feedback to registered users in the form of Fetch tokens, which are in the end financed by the real estate partners running these parking lots, who have an incentive themselves to reduce the load on those parking lots, because it's expensive to build new parking lots in a real estate market like Munich. 2, it's expensive to permit the building of those parking lots. And 3, a lot of times those parking lots are underutilized. So those people have an incentive to essentially incentivize their users to reduce the load on the lots. And the autonomous economic agents are how we manage to steer those incentives mechanisms. So in the bottom picture, you see a driver that's able to see where is going to be the most effective place to park. And you also see that because of better information and better incentives, the demand on those parking places has been reduced because some people just haven't parked, or some people haven't driven their cars to work. So it's a win-win-win for everyone. That benefits individual commuters and drivers. The drivers save time and money, and also receive incentives actually for good behavior. And let's say good behavior would be, for instance, parking in a parking lot that might be adjacent to your workplace, that's underutilized, or not driving to work 1 day a week or 2 days a week, instead of driving every single day and just parking in that one spot that you always kind of have to fight all your other coworkers for. For the property owners, it's great because it allows simplified permitting processes. Property owners, in order to get permits to build new properties here, are required to have plans for not only how they will meet parking demand, but if they have, for instance, less parking than they have potential users of a property, they have to be able to then show the permitting authorities that they have a plan for making that sustainable. Essentially, the tenants receive essentially price breaks on their rent, because they're not just renting out a single dedicated spot, but rather a portion of a spot, and the incentives mechanisms allow those spots to be shared effectively between multiple users and the demand to be lowered on any individual spot. The city council benefits because there's lower demand on the roads, and optimized traffic flow because there's less people out searching for a parking spot, just blindly driving around because they have better information. And then, of course, the CO2 impacts that we discussed. When you're not driving around blindly looking for parking spaces, obviously then your car, if it is a internal combustion engine, isn't producing CO2 and destroying the environment. So the elements of this project are, of course, the Fetch autonomous economic agents. We're building on the Fetch incentivized testnet, the second version. We're using the Connix parking garages, which Mikhail mentioned in his intro. There's actually 4 properties here in Munich, which we have direct access to, and where we're going to be later next month, actually mounting cameras and IoT devices and boards, and put it. That's what we mean by field testing, is actually bringing this stuff into the field. The hardware that we're using is based on Raspberry Pi. Is just standard off-the-shelf hardware that anybody can get their hands on, but we've got some pretty interesting software tricks up our sleeve, and we're building it in such a way that it's reliant on 4G router and battery backup. So at this point, it means that we can build in the lab and then directly deploy into the environments where these things can be tested, without having to integrate with third-party network systems, for instance. And how that's actually working is we're using Fetch's highly scalable testnet to record microtransactions. And those microtransactions, essentially, each of those parking garages has a daily budget of testnet Fetch, which can be sent out as incentives to individual drivers who have linked their pseudo-anonymized license plate to their wallet. And through that linkage, anytime that driver enters the parking lot with their car, the license plate is recognized using computer learning and optical character recognition, or machine learning, I meant, and we perform a pseudo-anonymization process to preserve driver privacy at the edge device. And then there is an exchange of tokens based on the fill level of those parking lots. So essentially, if you're parking in a very, very full lot, that will be less beneficial to you than if you're parking in a lot that's almost empty. And if you're parking in a lot that's totally empty, that will be more beneficial. And if you're parking not at all, that will be even more beneficial. And so you see here on the right-hand side in the wallet, you'll see your microtransactions ticking up, ticking up, ticking up, ticking up, ticking up until you park. And depending on where you parked, that flow of microtransactions will slow down, depending on whether that was a very full lot or a lot that was half full or a lot that was 3/4 full. And you'll also be able to see which parking lots are in real time full and which ones are not full, where it would be a good idea to park, and what kind of rewards you should expect to see, or rather what kind of reductions in rewards you should expect to see by undertaking a behavior that we as the overall system, we as the city council, we as for instance, the owners of parking garages don't want you to take, which is essentially parking in places where there's very high demand for that parking. And then once a day, all of this area that's been paid out in green in the version 2 incentivized testnet Fetch will trigger over into a mainnet Ethereum ERC20 transaction, and we'll do a settlement transaction into mainnet ERC20 based Fetch, which has true scarcity and true economic value, so that every day we take advantage of essentially the super high transaction speeds that we have on the incentivized testnet and on the mainnet when it comes, and also we're already now able to take advantage of the true economic value and true scarcity that the ERC20 tokens offer on the Ethereum mainnet. As far as the actual devices, as I mentioned, we're using edge computing here. The reason for that and what that means essentially is that all of the machine learning and all of the identification of the license plates, essentially the personal information, takes place at the edge device in the parking lot, and it actually doesn't leave that edge device and is then deleted. So we have a really, really strong privacy concept for all of this, because it can get pretty scary if you're talking about deploying cameras everywhere, and those cameras are smart and can recognize everything that's going on around them. So that's all taken into account. And we're using Raspberry Pis, infrared cameras, 4G modems. We have a battery management system that provides continuous uninterruptible power supply to all of that hardware. And to orchestrate all of that, we're using Kubernetes. So that basically what we can do is make a single image for one of these IoT devices, replicate that over a bunch of SD cards, plug those SD cards into the system on a chip boards, power them up, and then they just call back home to their cluster and say, "Hey, I need the image for all of the current agent builds that you want me to run." And then we're able to deploy rapidly and scale rapidly out to many, many different devices without having to set each device up individually. So this is actually a screenshot from a test that I did with one of our colleagues in England yesterday or the day before. And what you're seeing there is essentially that my parking agent here in Munich running on our IoT device is connected to the Kubernetes cluster setup in the UK, and actually pulling down those machine images and that agent framework and agent logic onto the IoT device in a containerized setup. This is what some of the first testing of the machine learning algorithms looks like. So basically, you have a license plate. This is in an indoor lab environment. You have a license plate with an infrared camera, and then we're doing contouring on that license plate to get the contours of the letters recognized. And then on top of that, we're running an OCR algorithm for optical character recognition to recognize which characters are in that license plate. And then on top of that, like I said, then there's some privacy algorithms running to do pseudo-anonymization to make sure that the data coming out of the IoT devices is not going to be something that could be leaked or correlated with individual users. This is what the garages actually look like. So these are real garages. This is really where this device is then going to be mounted up next month. And we have essentially algorithm set up that tracks if the license plate's getting a bit bigger, then we know that a car is coming towards us. If we if our machine learning algorithm sees that a license plate's getting smaller, shot for shot for shot, frame for frame, then we know that that license plate is going away from us. And based on knowing how many cars are in any one of the lots, the parking agents are then able to compute how many cars are in that lot at any one time, and to communicate with one another, between one another, to set the level of incentives that should be paid out to a car entering that lot at any one particular point. With that, I think I would jump right into questions. I think we've already got some questions here.
Thanks, Rebecca. Thanks, Michael. Yeah, go for it. I think the question number one we can take. What's the natural evolution of M-Zone solution? More regions, further enablement. How is this solution working with all the parties within a smart city, corporates, municipal, and governments, etc.? So yeah, you want to take that one? Yeah,
I can take that. It's a complicated one, but I give it a try. So the first part of that question, the natural evolution would be that we first finish up that project in the Connex neighborhood in Frankfurter Ring in Munich. Then we will most probably add other corporate buildings before we add public parking garages. And then we most probably will open up this formerly inaccessible parking space, not only to other tenants or other employees of the tenants of the buildings, but to the public. And that would be a very interesting move, because then we have something what many people want to have, especially city councils want to have, that everybody could search and find and use a parking space or within a corporate building that he was formerly unaware of, and that he wasn't allowed to approach at all. But he could not just find it, use it, park there, but he could pay for it and everything autonomously and automatically. And regarding the question, smart city, that is a very good question. So we are pretty much aware that it's not only about finding the right parking space, but it has many implications. Like our discussions with city officials have showed us that we want to optimize the city flow in general. And that has, again, something to do with other aspects of optimizing the city flow. But that would be two or three steps ahead. So we want to stick to what we have right now and just make the M-Zone project step by step bigger from here.
Yeah, it's, just to add to that, I think it's a new way of doing things, although everybody can see this is coming. To create new business models, it will take some time. So we want to focus on a very narrow parking problem, which actually generates roughly 30% of congestions in different cities, depending on which city you're talking about. Just as Rebecca was saying, people searching for spaces causes congestion. So I think that's for that question. We've got 3 votes on one question, which is, what are Fetch.ai's main goals in 2021? Well, hopefully COVID will be put to rest somehow. But as you would have seen this year, and we're going to continue with that next year, we are bringing the technology to the world. We're going to commercialize it. We're going to find many more applications. We're going to trial different field trials, which we will then grow into much wider areas. And that really is what Fetch needs to do at the moment, and that's what we're focusing on. So hopefully that answers that question. There we go. I think there's another question about how can Fetch adopt to other commercial businesses and how can it grow up from there? I think it's. Fetch is. Fetch is what connects all the Fetch network and all the services. But what we need to focus on is how can we build businesses which actually use the Fetch network, Fetch agents, and how can they deploy new types of business solutions based around Fetch. Fetch's technology using machine learning, using a multi-agent system. Because all of these systems, as I explained in the presentation, they all utilize Fetch. So really what the focus here is to take commercial businesses more narrowly focused in the beginning and try and give them a trial of how the business could benefit from the Fetch technology. And that's really what we are going to do over the next coming years, which will then hopefully increase the adoption of the Fetch network and ultimately Fetch. Let's pick up one. So the parking app in Munich with AEA will be run on ETH2 mainnet with ETH. Well, no, that's the short answer. It will be, I think if you got that idea, perhaps maybe let me re-emphasize what Rebecca said, is we'll be running on Fetch's network. It will be using Fetch as the token, and will be the only reason why we don't want to restrict the settlement is because the settlement is not something we feel we should stop people from choosing, because that would be actually detrimental to the growth of adoption. So we want people to adopt and use our service, pay in Fetch or consume Fetch or exchange value in Fetch, and we will not restrict them from settling whichever currency they want. I mean, they might want fiat currency settlement, they want ETH, they want BTC, USD, we don't care. We will hand that across to them. But to use the network, consume the service, you have to use Fetch. Cool. Well, I can see you get a thumbs up. This one I think probably is for you guys. Munich City Council expressed some interest in the use of AEAs for increased parking efficiency and revenue? Question mark. That's for you.
Yeah, I cannot answer this question directly. We have conversations with many different parties about that, starting with the landlords, then with Munich officials, with guys from the university, because there are many mobility projects going on at the moment. And there are so many different mobility projects that one aspect of our work is to trying to combine some of these projects or integrating M-Zone into one of the running projects. So that is complicated because it's a political affair. It's a complicated thing, but we are working on it. Yes.
I think you'll always appreciate, and I think probably most of our listeners and viewers are also going to appreciate that it's not very easy to mobilize a whole city to do something. We're getting to this stage, which means that we are in conversations. I think let's just leave it at that. We're going to have a full-scale deployment. Well, that's the objective. So I'm going to pick one for you, and then these are the last two questions we're going to answer. And I think this one is quite interesting, I find. Can you share what is the success criteria for M-Zone, and what needs to happen for this to be rolled out in production for use?
Yeah, so the success criteria are obviously whether the stakeholders we had on our slide that should benefit from M-Zone will agree with that they benefit. So if we, for example, can measure that people don't use their personal cars to drive to work, but instead use public transport, and we see that, and we see a change of behavior, then this would be one aspect. The other aspect would be that a real estate developer says, okay, with that concept, I'm able to save a lot of money because I'm able to present my new project to the city council in a way that I have that I don't have to provide much parking space, but I can focus on the actual offices. And another one would be if an individual, an employee, or in future somebody who searches for a parking space says, I mean, that is a great system. I love to use it, and I constantly use it because for me it's a meaningful and helpful and benefiting system. So there are many different aspects to that.
So yeah, so just to add, I mean, very concrete steps would be, to measure how much the employee started using public transport, to measure how much the parking space was used, and to measure from the point of view of the building owner if they actually saw their kind of efficiency improve. Those are the three key things. So the last one here, can we expect partnerships with large companies in the future? And I'm guessing this is for Fetch.ai and or Datarella as well. Well, from our side, definitely. And I'm very confident about it because we are already working with some companies. And as we feel, as the companies feel comfortable, as we feel comfortable that we have something to announce, I'm sure we will let you all know. But certainly we are communicating, we are working together, and we are actually deploying things and solutions. But bear with us. The bigger the corporation, the longer it takes.
So I would second that, but I would add some other aspects here. Since we at Datarella are a comparably small company with the giants of like Siemens, Bosch, or those, we are very good partners to them because we are agile and we can try and test out things they can't because they aren't that agile. And before a large company is able to start a new project like this, they would have to find budgets, they would have to find the okays of the C-level and so forth. And that is a lot easier in small companies. So we are regarded as a quite good partner for them. And I think that's the same with Fetch.
I think we'll just close at that. I think, I'm sorry, I think we're running out of time. One more question. What do you hope to achieve with the field trials program? Well, adoption is really ultimately the goal. And we hope that more and more people will see the field trial. There will be a lot more interest, and we all are positive that we can show the improvement in efficiency and this new, much more efficient way of transacting and bringing multi-stakeholders kind of systems together. So we hope that this trial will bring a lot of attention and more adoption. So I think on that note, we'll close this. Thank you very much, guys. Thank you, Michael. Thank you, Rebecca. It was really appreciated, and thank you for being such great partners. We are really enjoying working with you guys, and we hope to see more such partners. I would like to invite you people to start building on Fetch. We're now ready to build practical commercial solutions. And thank you all for attending. Thank you for the great questioning. Really appreciate your support, and we can see plenty of questions. And while we've been speaking, I think some media coverage has come across in terms of this M-Zone project. So thank you, everybody, and until next time, we'll see you soon.
Thanks, everybody. Bye.
Thank you. Bye-bye.